Hello students, today we are going to see about features of 8086 in microprocessors and microcontrollers. So 8086 is a 16-bit microprocessor. Why it is called 16-bit microprocessor? The arithmetic logic unit and internal register and most of the instruction whatever it has been accessed by the 8086 are 16-bit only. So it can access only the 16-bit data at a maximum. So it is called 16-bit microprocessor and it has 16-bit data bus. So it can read the data either from the memory or from the input output port, and also it can write the data to the input or to the memory maximum of 16-bit at a time. And also there is a possibility to transfer 8-bit at a time also. So maximum of 16-bit it can transfer, and also it can transfer 8 bits also at a time. 8086 has 20-bit address bus. So 20-bit address bus in the sense it can access about 2 per 20, that is 1 MB of memory locations it can access, and each memory location can store only 8-bit data. So 8-bit data is nothing but byte. So it can store only 8-bit of data, that is a byte of data only it can store in one memory location. So usually how much bit of data it can access? 16-bit data at a time it can access maximum. So in order to store a word in the memory location, it requires 2 consecutive memory locations. So 1 MB of memory location it has, and each memory location it can store only 8-bit data. So 2 consecutive memory location it requires in order to store a word of a data. And it can generate 16-bit input output addresses. So it can access about 2 power 16, that is 65536 input output ports. And it provides 14 16-bit registers. For example, it has internal registers like AX register, BX register, CX register and DX register. AX is nothing but accumulator, BX is nothing but base register, CX register can act as a count register, and DX particularly it is used for division and multiplication. So 4 basic general purpose registers are there, and apart from that 2 pointer registers are there, stack pointer and base pointer, and 2 index registers are there, that is source index and destination index. And then apart from that it has 4 segment registers, that is code segment, data segment, extra segment and stack segment registers. Apart from that it has instruction pointer. So instruction pointer is one which points to the offset address of the next instruction. And apart from that it has a 16-bit flag registers. So totally 8086 provides 14 16-bit registers. And 8086 has multiplexed address and data bus. So what is the use of multiplexed address bus? Actually 8086 is a 40-pin IC where both address and data pins are multiplexed and are provided. For example, if I have here the address bus, totally how much address bus you have? 20-bit address bus, and data bus is 16-bit data bus. So if you want to provide a separate line for each things, 20 plus 16 is 36 pins you require in the pin diagram. But if you are using the multiplexed manner, 16 bits of data bus and 16 bit of address bus can be multiplexed. So it can be used as a data bus also, and it can be used as a 16-bit address bus also. Okay, so the same pin it can access as a address bus or data bus according to our requirement when it is multiplexed, so that the number of pins are reduced. But anyway, it will slow down the transfer of the data. And 8086 requires one phase clock. So clock is nothing but a signal which is used to provide a common internal timing for all the synchronization operation of all the units whichever it is available in 8086. So it has 33% duty cycle, that is T on period is only T by 3, that is 1 by 3. So 1 by 3 into 100 is nothing but 33%. So on period is only 33% and off period is 67%. And 8086 is used to perform bitwise, byte, word and block operations also. So it can perform arithmetic and logical operations on all these possibility, that is bitwise operation, bytewise operation, wordwise operation, also block operation, and also it can perform multiplication and division. And 8086 can operate in two modes. One is minimum mode, maximum mode. Minimum mode in the sense only one single processor is available in the system. Only one 8086 is available. Maximum mode means more than one 8086 are available in the system. So if it is only one 8086, it is called as minimum mode of operation. More than one 8086 is available, that is 2 or 3 8086 are available, then it is called maximum mode of operation. If it is single mode, that is minimum mode, then all the operations are handled by that particular CPU of the 8086, that is the control signals, everything required by the memory and input output devices is sent by that 8086 itself. If it is multiprocessor, then more than one processor will be there, then the communication thing is very risk, that is each and every processor has to transfer its data, has to communicate properly. So in order to make it proper, we require an external bus controller called 8288. Also 8086 supports multi-programming. Multi-programming in the sense parallelly you can execute multiple programs. So if you have two or more processor in the memory, at the same time all those things can be executed in a time multiplexed fashion. And 8086 has 16 byte of instructions, can store 16 byte of instruction in a queue. So what is the use of queue? So by storing the 6 byte of instruction in a particular queue, we can speed up the instruction execution. For example, you have two units in 8086. One is your bus interface unit and execution unit. In bus interface unit only you have a queue, and in execution unit you have other registers, control unit, everything. So bus interface unit, there you have a queue where it can store a 6 byte of instructions, and where parallelly while fetching, the decoding and execution operation is performed in the execution unit. This process is called pipelining. So by storing or fetching a 6 byte of instruction at a time in a queue, what happens? Parallelly you can do the decoding and execution process in the execution unit. So 8086 supports pipelining because of this queue in the bus interface unit. And 8086 supports powerful instruction set. So it has a variety of addressing modes like register addressing mode, immediate addressing mode, direct and indirect, using the base index register, base register or index register mode, or the combination of all. You have relative addressing mode and implied addressing mode, which has been supported by the 8086. So as I said before, it is 40 pin IC and it can execute instruction at 2.5 million instruction per second. So this is all about features of 8086. Thank you.